So let's talk about dy over dx. When we do dy over dx, we're doing the derivative of y with respect to x. But in the case of our polar functions, our x and y functions are going to be in terms of theta. So when we do that dy over dx, we need to find the derivative of y with respect to theta and divide it by the derivative of x with respect to theta. When we do that, the thing that we need to keep in mind is that product rule that we would have had to do with our radius times our sine, or radius times our cosine. So we end up getting this derivative, which is really just the derivative of y with respect to theta divided by the derivative of x with respect to theta. This is just using that product rule on both. So our second derivative, just like with parametrics, we need to take the derivative of what we found again, and then divide it by that dx over d theta. So it's exactly like parametrics, and it's because we have a derivative that's not quite with respect to the variable we want. So when we're doing anything with the dy over dx, we may need to spend a little bit more time working with these different functions. So what is the slope of the line tangent to the polar curve r equals 1 plus 2 sine theta at theta equals 0? So line tangent. This is what tells us we want dy over dx. We want the slope of the line tangent to this. So the list of things that we need to do. We need to find the equation for x. We need to find the equation for y. We need to find dx over d theta. We need to find dy over d theta. And then after we have both of those, divide dy over d theta by dx over d theta. The last part that we're going to do is we have it at a specific point, so we are going to plug in the point theta equals 0. So this is our list that we need to do: find x, find y, take the derivatives of each with respect to theta, and then plug in 0. So we know that r is equal to 1 plus 2 sine theta. So x and y, we have x is equal to 1 plus 2 sine theta times cosine. We also know y is going to be 1 plus 2 sine theta times sine. So we have found x, we have found y. So we're good on this one, we're good on that one. So now we need to find the derivatives of each of these. Both of these derivatives are going to include product rule because of the fact that we have 2 sine theta times a cosine, or 2 sine theta times sine. So dx over d theta. So the derivative of 1 plus 2 sine theta, derivative of 2 sine theta is going to be 2 cosine theta. Multiplied by the original of the other one, so times cosine, plus the derivative of cosine, so negative sine theta times 1 plus 2 sine theta. Because we're going to be doing some other stuff with this later, it may be nice to simplify what we have here. It may not be nice to simplify what we have here. It just kind of depends on what we see, what we do, all of these kinds of things. So we have 2 cosine squared theta. I'm going to multiply these out. So I have negative sine times 1, negative sine times 2 sine. So negative sine times 1, so minus sine theta, minus 2 sine times sine, so we have sine squared theta. So 2 cosine squared theta minus 2 sine squared theta. Okay, now we're going to do dy over d theta. So same kind of thing, derivative of 1 plus 2 sine theta. We have 2 cosine theta times sine theta plus the derivative of sine theta, which is cosine theta, times 1 plus 2 sine theta. This one does not simplify as nicely as the other one does, but we already wrote out the other one the way we did, so I'm going to just rewrite this. So cosine times 1 to sine theta cosine theta. Okay, so I now have dy over d theta. I have dx over d theta. We need to divide dy over dx. So we're going to have a big fraction here. So dy, I have 2 cosine sine plus cosine theta plus 2 sine theta cosine theta. Perfect. And then on the bottom we have 2 cosine squared theta minus sine theta minus 2 sine squared theta. Okay, I can simplify this if I want to, but if I don't have anything to do with it, I'm just going to leave it alone. So our last bit here is to plug in 0 for theta. So I have dy over dx where theta equals 0. So I have 2 cosine of 0 sine of 0 plus cosine of 0 plus 2 sine of 0 cosine 0 divided by 2 cosine squared 0 minus sine of 0 minus 2 sine squared of 0. So when we're thinking about the unit circle, 0, we have our cosine, our x value is 1, sine is 0. So I have 2 times 1 times 0. So all of that's going to go away. Plus 1 plus 2 times 0 times 1. On the bottom, I have 2 times cosine squared. So 2 times cosine of 0, 1, squared, still going to be 1, minus 0, minus 2 times 0. So we have this goes to 0, this goes to 0, this goes to 0, 0. So we have 1 on the top, 1 squared is 1, 2 times 1 is 2, so we have an answer of 1/2. The process here gets kind of messy, and to keep in mind, this is still only the first derivative. So let's look at one more problem here, which is given dx over d theta is cosine, given dy over d theta is 2 sine. We want the second derivative of y with respect to x. So the first thing that we want to know is what is dy over dx? Well, dy over dx is equal to the derivative of y with respect to theta divided by the derivative of x with respect to theta. So we have 2 sine theta cosine theta. One of the things that's really going to help us here is to know those trig relationships. So I know sine over cosine is the same thing as tangent. So 2 sine divided by cosine is the same thing as 2 times tangent. So the next thing that we need to do is we need to find the derivative of what we just found. So d over dx, d over d theta. So we want to take the derivative with respect to theta of the thing that we just took the derivative of, dy over dx. This is going to be the top of my fraction. So the derivative of tangent of theta is secant squared, so we have 2 secant squared theta. In order to get what we want, the second derivative of y with respect to x twice, we need the derivative with respect to theta of dy over dx divided by dx over d theta. Again, we know the top part of this is going to be secant squared theta. And they gave us dx over d theta in the problem, which is going to be cosine theta. The really nice thing with this particular problem is that dividing by cosine is the same thing as secant. So this is really 2 times secant cubed theta, because we already had 2 and now we're multiplying it by another secant. So derivatives, if you can do parametrics, then polar isn't too bad. The big difference is that we're working with theta, so a lot of times unit circle is going to be involved, which makes it a little bit harder for people if they don't know their unit circle values.